In next few sections we are going to learn about addition of vectors, and I am going to talk about tip tail method, parallelogram method, and polygon method. These three methods are graphical methods. And then we are going to discuss analytical method, this method requires finding component of and use these components to find the resultant vector. This method requires calculation. You can do it by using calculator, and then you can find the magnitude of the resultant, the direction of resultant, all those things mathematically. So before we talk about graphical method, let's see how the vectors are represented graphically. Graphical representation of vectors. So the vectors are represented by arrow, length of the arrow is proportional to magnitude of the vector. Okay. Direction of arrow represents the direction of vector. So if you have a vector A, that can be represented by an arrow. You can write vector A. Let's take an example. Suppose someone drives 50 miles along plus x-axis or along horizontal, and you can say that this horizontal is going along plus x-axis. You can set your axis this way, so your plus x-axis. So if I have to construct a vector for this displacement, so I can choose any scale, like I can say that 10 miles is 1 centimeter. If 10 miles is 1 centimeter, so I can draw a line 5 centimeter long, and I can place the tip of the arrow like this. So this is, you can say that this is displacement vector D, and scale is 10 miles is equal to 1 centimeter. So this vector represents 50 miles of displacement along plus x-axis. Because this is 5 centimeters, so this is 10 mile, 20 mile, 30 mile, 40 mile and 50 mile. Let's take another example. I can say that there is a force working on an object. Force is 50 Newton along y-axis. The force is 50 Newton along vertical y-axis. So what I can do, if I have to draw 50 Newton, I can choose a scale. Like if I choose 5 Newton as 1 centimeter, so I have to draw how many centimeters? Then I have to draw a 10 centimeter. If I choose 5 Newton as 1 centimeter, then I have to draw a vector 10 centimeter long. If I choose 10 Newton as 1 centimeter, then I have to draw a 5 centimeter long vector. Okay, so you can represent this vector as like this. This is 5 centimeter, 10 Newton, 20 Newton, 30 Newton, 40 Newton, 50 Newton. Okay, so you can say this is your force. This is along plus y-axis. So if this is your x, and this is your y, this force vector is along plus y-axis. If someone is traveling, suppose this is your east, this is your west, this is your north, and this is your south. If someone is going 20 miles north of east, so north of east will be, this is east, this is going to be north of east, this would be midway 45 degree. So you can make a vector at 45 degree angle. So suppose this is your, how big this vector should be? You have to choose a scale. Suppose I choose 5 miles as 1 centimeter. So how many centimeters I have to make? So I have to take a protractor and measure this angle 45 degree, and then you have to draw a vector like this. So you can say that this is the vector D, so you have to write D like this. Make sure that you measure this angle before you draw this line 45 degree. Okay, after measuring 45 degree using protractor, and you can draw this vector. So
Vectors
are represented by arrow. Okay, there could be several vectors. The length of the arrow is proportional to the magnitude of the vector, and this arrow points towards the direction of the vector itself. So vector could be in different directions depending on their orientations. Okay, if vector A is like this, B like this, C could be something like this, but they are a straight line. They are a straight line.
Now we are going to discuss.
You can say that vector addition using tip tail method. How can we do this? Suppose there are two vectors. If this is vector A and another vector is B, this is vector A is a straight line, this is vector B is a straight line. If I want to add them, what I can do, I can use tip tail method. What is tip tail means? You have a vector, this is the tip of the vector, this is the tail of the vector. So for vector A, this is the tip, this is the tail. For vector B, this is the tip and this is the tail. So what you do, you draw vector A first. This A should be exactly same length, same direction as this vector. Then draw vector B, or you can drag vector B over here. In other words, you draw vector B exactly same way. Okay, so you slide this over, in other words, you put the tail of vector B on the tip of vector A. Then connect the tip of B with tail of A. Okay, make sure that you use the ruler. This is vector R. Vector R is sum of vector A and vector B. Okay, so this is called tip tail. This is vector R is vector A plus vector magnitude. This length is the magnitude of R. Alright, from here to here, this length, if you measure it, this will give you the magnitude, and this direction of this arrow gives the direction of vector R.
Now we are going to discuss
vector addition using parallelogram method. Okay, suppose you have two vectors A and B. This is vector A and you have another vector b somewhere. You have vector b. How to add these two vectors using parallelogram method? What you have to do, you have to make parallelogram with the help of these two vectors. Okay, so I'm going to draw exactly b of same size, same direction, same length over here. This is vector b, vector a and vector b, and then I can complete it by making a parallelogram. So what is parallelogram? Here you draw a vector parallel to vector A. Okay, it has to be same length as A. Then you draw B over here. This is called parallelogram because this and this is parallel, this and this is parallel, and the resultant is going to be diagonal. So if you suppress this, look at this. If you suppress the upper half, this also looks like a tip-tail method. If this is like a vector A, this is like a vector B, and this is your resultant. Okay? But you can do it by making a parallelogram and then drawing the diagonal. That gives you a result.
Let us discuss
Polygon method. You know, if you have many vectors, like A, B, C, D, I need to find the sum of all vectors. How do we do this? We will draw all vectors, you know. So first we will draw vector A exactly the same way. Then on the tip of A, I will put the vector B exactly the same way it is, same size, same direction, everything same. On the tip of vector B, I will place the vector C, same direction, same length, exactly same. On the tip of vector C, I will put vector D, same direction, same length, exactly, everything is same. Now connect the last vector, the tip of the last vector, to the tail of the first vector. This is your going to be resultant, R. One thing I would like to emphasize that, you know, though I am, for explanation, I am doing this without using ruler, but when you do the actual problem of solving vectors, you tip-tail method
or
parallelogram method or polygon method, you are going to use ruler and protractor to make sure that the lengths are correct, the angles are correct, and then it will give you the correct result. One has to take extra while drawing these vectors. You know, if you make a mistake in drawing, your resultant will not come right. Okay, there will be error in resultant. Its direction can change. If your directions are not proper, if your length is not proper, all the things can make. One has to be very careful while doing vector addition using graphical.
Now we are going to discuss
Component or analytical method of vector. First of all, let's understand what is the component of vector means. Components of vector. Okay. Suppose you have vector A and it is making theta angle with x-axis. Let's say this is my x-axis and this is my y-axis. This vector A is making angle theta. This vector A is making theta from x-axis and from x-axis, and suppose I need to find what is the x component of this vector A and what is the y component of this vector A. How can we do this? What is x component means? If I make a projection on x-axis, okay, from the tip of this vector, if I make a projection on x-axis, the length from here to here, from this point to this point, is going to be the x component of vector A, that is ax. Okay. If I project this on y-axis, the length from here to here, this vector is the y component of vector A. Okay, this ax has a magnitude from this point to this point. Ay has a magnitude from this point to this point. All right. This is the magnitude of Ay, this is the magnitude of Ax, and this is your original vector A. This is X component, this is Y component. Will be, what will be the magnitude of Y component? How much Ay? What is the magnitude of Ay? How much this is going to be? Now let's see that if this is Ay, from this point to this point is Ay, so this is also going to be Ay. Okay, this magnitude is Ay. And this magnitude is Ax. From here to here is magnitude is Ax. From here to here magnitude is Ay. This is a right angle triangle. Can you see that this angle, this triangle? Here is the angle is 90 degree. This angle here is 90 degree. So this is a right angle triangle. And you know, in right angle triangle, sine theta is what? Sine theta is going to be Ay over magnitude of A. Okay, so the A is magnitude of vector A. Ax is magnitude of vector Ax. Ay is the magnitude of vector AY. When I say magnitude, magnitude means the number, how big it is. Alright, so sine theta is equal to AY over A. So if you simplify this, AY is equal to A sine theta. What is AY? It's a Y component. Okay. Cosine theta is AX over A. So AX is going to be A cosine theta. So AX, so this vector AX, what we got, X component is A cosine theta, and AY is Y component. AX is the magnitude of X component of vector A, that is A cosine theta. AY is the magnitude of Y component of vector A, that is A sine theta. Okay. So if you have any vector, suppose I say you have vector F, and if this is theta, if you choose this is your X, this is your Y. So this component is going to be Fx. Fx is going to be what? This is going to be from here to here. Is X component is going to be how much? F cosine theta, and this is going to be F sine theta. This axis X and Y I have chosen, so I am calling this as a X and this as a Y. Okay, I can do this without referring to the axis. I can simply say that if this is F, this is theta, can you tell me what is this component is going to be? The leg that is directly connected to theta, this goes F cosine theta. What will be the component, what this component is going to be? This is going to be here F cosine theta, and this is going to be here F sine theta. You know, the leg that is directly connected to theta, it goes cosine, F cosine theta. Okay, and see, it is, this one is not connected to angle, this one is goes F sine theta. I can generalize this. Suppose I say that my F is this way, and can you please tell me what, if this is theta, what this component is going to be here? This component is going to be here F cosine theta, and perpendicular to this one, the F sine theta is going to be this way. Okay, F sine theta is going to be this way. So the leg that is directly connected to theta, it goes cosine, the other one it goes sine. Alright, I'm saying that in future chapters you may have angle and forces at different directions. So you know, even I don't refer X and Y, you should know that the leg that is directly connected to theta, it goes cosine, the other one it goes sine. Okay, I can change this. Suppose my F is this way. If this is theta, so how much this is going to be, this component? See, it is directly connected to theta, it is going to be F cosine theta, and the other component is going to be F sine theta. If I have another vector, suppose I say that d, and tell me how much this component of d is. If this is theta, this component is going to be, this is directly connected to theta, it goes d cosine theta, and the other one it goes d sine theta. Okay, so the x and y we choose for our convenience. Okay, but this can be generalized for different orientations. Alright, and you can see that the one that is directly connected to theta, it becomes cosine, the other one becomes sine. So I can use it for any other orientations, the same